robot that's too big for the table. Where's my computer? Here's my computer. Steve, you're going to come up after me, okay?
Okay, I'm going to come after you.
Come after me. All right, so, full disclosure, I work at Nito Robotics. The Nito robot features a LiDAR that spins at 5 hertz, takes 360 snapshots per revolution, and you can thereby discern obstacles in 360 degrees. And so there's a ROS package for it. In fact, the HBRC SIG Special Interest Group meets the penultimate Wednesdays at Maker Nexus in, help me, Sunnyvale? Sunnyvale, beautiful Sunnyvale. FloorBots, okay. So a FloorBot is a robot too big for the table. And there we go. I drove around and I made this map, and my robot's over there. And, oh, where's my mouse? I'm going to come up here, and I'm going to choose 2D nav goal, and I'm going to go to this side of the room, and point, press, and drag the direction I point in. The robot will orient itself that way. That's its pose. And this is ROS, by the way. This is the RViz ROS visualizer, and it's all three-dimensional. It's pretty cool. You can see the LiDAR scans there. All right. Now, BotVacs, I mean, you can get them used on eBay for like $200. And, you know, you could put the Raspberry Pi in there. We've got a package. Oh, I know. We were talking about the HBRC SIG, the Homebrew Robotics Club Special Interest Group. We meet the next to last Wednesday at Maker Nexus in Sunnyvale. And our special interest is ROS, so we do a lot of this stuff. But anyways, you can put it on the Raspberry Pi, and it's navigating, nothing up my sleeve, okay? And I'm going from one end of the room, and I'm going to have to manually click, so I guess this is like FloorBot Challenge phase half also, but regardless, you get the point. So, questions? Yes, Steve.
That map right there, did Ross go out and do a survey to get that map?
Did you see me driving the robot back and forth earlier? That was the mapping.
So those look like infrared spots, the red kind of warm spots, or different colors.
You know, what it does is the global parameters. Then you get this blue area that's called the inflation barrier, and that's how your tolerance is, how close you want to get to the wall, and that's all adjustable in the parameters. Then when you see the robot get close to something, you'll see the local cost map. This is the global cost map. And so the first thing I did, Steve, was drive around and using a ROS package called G-mapping, grid mapping, and that way I was able to create the map. Okay? Then you save that map, and you kill the grid mapping, and you load in the navigation stack, which contains 2 elements, move base, which is your path planning, and then AMCL, your localizer. Yes, Danny?
How granular is the sensor? Like, how
It's
fine is the detail?
it's 360 points. It spins at 5 hertz. But I mean, you get a good intuitive idea, you know, just looking at this, you know, how it works. See? You see the scan lines?
So that's no GPS at all. It's all quadrant-ing.
Yeah, well, and if you look at it, what ROS does, and its transforms, is the XY axis, that's the planar surface, the floor, and then the angular, the Z axis is the angular pose of the robot, so it defines the direction the robot's pointed. And again, so here, you know, I take this map, and I come up to 2D nav goal, and I click, and I come down here, and I point, press, and drag, and the robot shall autonomously navigate to the other end of the room. So that's kind of sort of a FloorBot challenge.
It's CAD, isn't it?
Pardon?
That's CAD, isn't it?
Well, this is ROS Robot Operating System's a framework. And what you're looking at here is its visualizer. Okay, so again, we've mapped the XY, and we've saved it, and then we load in something that knows about where the robot is relative to the area around it, and it's able to navigate that way. Cool. Thank you. Thank you very much. You can call. Yes?
So the personnel, a whole bunch of
enhanced packages for Ross Kinetic, including enhancements for move base. So one of the limitations here is you have to give it a navigation goal one at a time. It's now possible to have several goals. And go from goal to
Dr.
goal to goal.
Alan Fetterman, ladies and gentlemen, he knows something, okay? That's awesome. All
Well,
right.
just like you, I
All right.
have the illusion of intelligence.
Yeah, we're overrated, right?
Yep.
All right, very fine. Steve, okay?
Yeah.
Hello, all right, thank you very much. As the Nito turtle here will autonomously navigate back to the other end of the room. Again, nothing up my sleeve.
Unless Steve's robot gets its cross wrapped.
Thank you very much. Steve, you're on.
Yeah.
Can you drive it up the ramp?
Yep. Yeah. Try this here.
He's attempting to drive it up the ramp. It's challenging, huh?
Yeah, I just got this working, and I think I might have the. I might have the motors.
why we call it the
down.
challenge, the
I think I might have the
HBRC
motors
challenge.
turned down a little bit.
I'm sorry, what?
I think I might have the motors turned down a little bit.
He thinks he may have the motors turned down a little.
Come on, robot.
He's spinning out, dude.
I don't think I have enough juice going in there.
See if it'll go down the ramp.
More batteries in it.
All right. Well, let's just give it a little bit of a hand here. It was really zipping along the other night, so I actually turned down the motor speed. I think I might have turned it down a little bit too much. So, okay, this is going to be kind of a short demo here because in true homebrew fashion, I just got this working this afternoon. I do have, as you saw, it does go forward a little bit. Maybe I could come back in a little bit, and I could tune the.
Steve, you should say a word about the effort and how you came about
Put
with
it up on the
this
table.
robot. That's quite an accomplishment.
Put it up on the table.
Okay, so you want to put it up on the table? All
Put it
right.
up on the table and tell us about it.
All right. Let's just come on up here, robot.
Oh, you did that well.
So responsive.
Ooh, it almost does the table block challenge just sitting up there.
Hey.
It's not fun,
I
Des.
don't want to go for 4.
Be careful now. Okay. Nothing says it can't be remote control.
So we have forward and back. We have
There's that new car
steering.
smell.
So this is just right now. This is all just running on a Arduino Mega and Robotics. I'm using the L298 motor controllers. Using the same motors as Marco. And this is a 3D. This is mostly 3D printed. I've actually, since the last time I was here, I have replaced some of the 3D printed parts with metal because the one thing I've noticed about the yeah, see that one's doing it. One thing I've noticed about the carbon fiber nylon that I was using is that it will support the weight of the rover. It will drive it, as you can see, but the nylon under weight, under load, actually it bends just a little bit. and so it deflects, and that leads it to kind of skewing a little bit. So the drive shafts here are still 3D printed, but there are other support structures that I've gone to metal on. I think maybe if I printed them out in polycarbonate, that would be stiff enough, and that would support the weight. In terms of like, so part of like what was going on here, part of the project here is like, what can you 3D print, and what do you need an actual shop for? What do you actually need like a metal shop for? And I think with the right, appropriately stiff materials, unless you're talking like BattleBots, or unless you're talking something that needs structural metal for hobby robots, I think the answer is really not much of anything anymore. Additive manufacturing, I think, is definitely the way to go for small to medium-sized projects, and even larger projects. There's actually a real move forward now into 3D printing and then metal sintering. So 3D printing parts in a matrix, and then putting them into a sintering furnace, and then you get a solid metal part out of it, and I'm really, really interested in that. So this is, I actually have a name for this now. Camp would be very happy. This is SPR Tenacity, after the Mars rover's Opportunity, Spirit, Curiosity. So this is Tenacity.
I like that.
And the SPR stands for Spare Parts Rover. This is mostly spare parts from Service Robot Labs, my former startup. And that's kind of how I got started on this, is that I had a bunch of robot parts laying around after company closed down, and then the Sawpy rover on Hackaday showed up, and they showed off a 80%, almost 90% 3D printed robot with some 80/20, and that's pretty much about it. And whatever other parts you have on hand. So you have the rocker bogie steering.
Speak up.
We have a rocker bogie steering, and it can kind of articulate like the real Mars rovers can over obstacles and things like that. And I have a little button pad here, soldered and hooked up into an Arduino, and we can do things like that. So these are Dynamixels. These are the AX12s. Yeah, that's pretty much about it. I'm going to go and take this back, and I'm going to turn the motors up a little bit, and hopefully get it driving around a little bit better. I would also like to thank Circuit Launch in Oakland, which is the makerspace that I'm currently the resident roboticist in off-road robots at. They've been great in providing me with space to work on this, to build out permanent desk, or at least like a regular desk that I can leave stuff on, and access to parts and tools and things. I was able to actually cut the metal parts on the drill press there. So they're awesome. They're in Oakland. Just wanted to give them a little bit of a shout out, because they've been super awesome in giving me a space to work on my rover at. So.
Ralph Hips.
Which meaning of like?
Isn't it the one that was on the table earlier?
It was.
Did you guess, what was his name? Slime?
Huh?
Bile, sorry.
Slime body.
So it's going to go from one end of the room to the other and back.
Theory.
In theory.
Navigating.
What's that? What's navigation?
Wait. Navigating.
Oh no, like that's headed right for us.
Not happy. One more try, and then
One
I'm
more
gonna
try.
give up.
Eva, you want to go ahead and set up your table?
they're out for a second? Okay. Recognize that as an obstacle? Point it this way so it'll work.
Or when it gets close, you can just ask him to.
Okay. Yeah. Here we've got a bit of a special presentation, a robotics class, right, Eva? What's the name of this class?
These two are my year-round
Watch out, Steve.
robotics club.
Okay, watch out.
Only.
And those only robotics club. Here are the rules.
We meet every Sunday